In example 6a, we determined that f and g are inverses of each other. So now in b, I'd just like to kind of further clarify what that means. And I changed the f inverse to just be g because I think it makes more sense that way. So we're going to find f of g of -6. So remember, we can write that like this. And so what that means is one way we can solve this is to first find g of -6, and then whatever we get, we'll plug that into f. So I'm going to start with g of -6. And if you remember, g is the function 1/3 times x minus 2. So I'm going to plug in that -6 wherever x was. And so that's going to give me, well, 1/3 times -6 is -2. -6 divided by 3 is -2. And -2 minus 2 is -4. What I want to do next, then, is plug -4 into f. So since g of -6 is equal to -4, then now I can find this by finding f of -4. Now, if they are truly inverses, what should I get here? Remember that inverse functions undo each other. So g will start with a number, give you an answer, and then if f is its inverse, then it's going to take that answer and map it back to the beginning. So this should give me -6. So let's see. If you recall, the function is 3 times x plus 6. So now I'm going to take -4 and plug it in there. So 3 times -4 is -12. And -12 plus 6 is, in fact, -6. So see how I started with g, does something to x and spits out -4, but then f is going to take whatever you got and undo it and take you back to -6. That really shows you what inverse functions do.